Let's take a look at this differential equation. We have y double prime plus x times y is equal to 0. And we want to find the series solutions for that. So we have a regular point at x is equal to 0. An ordinary point, sorry. We have an ordinary point. And so our series solution will look like c sub n x to the n when n goes from 0 to infinity. So we need the second derivative, but in order to do that, we need to get the first derivative first. That's n c sub n x to the n minus 1. N starts at 1, goes off to infinity. And then y sub 2, or y double prime, is going to be n times n minus 1, c sub n, n minus 2, with your sum, your series starting when n is equal to 2. It goes off to infinity. So here we go. We have the series for x, or for y double prime, and the series for y. So the series for y double prime can go here in the first slot, and then we have a plus x times the series for y. So this is our series. Now we have a couple of things to take care of. One of them is this x can go inside, so that goes inside, and then this increases the power by 1. And then now we want to try to match up the powers of x. So we have x minus 1, or x plus 1 here, and we have an x minus 2. So we're going to need to do a couple of things, and one of them, we're going to replace n with k plus 2. So that's for the first series. For the second series, we're going to replace our n with k minus 1. So we're going to subtract 1 to all the n's in here, and then add 1 to the starting point. All right, let's see how this is going to go. Let's do it one by one. Let's take care of this relationship over here. This is going to be get replaced with k plus 2 minus 2. That's just going to be k, and this is going to get replaced with k plus 2, or k plus 2. K plus 2. Here, this is k plus 2. K plus 2 minus 1 is k plus 1, and then this is going to be, the n is going to get replaced with k plus 2. And then our index will start with 2 less than 2, and that's going to be 0. So this is our first series rewritten. Our second series, we're going to replace the n with the k minus 1. So this is going to give us our k here. So the n is equal to k minus 1. And then now the n is equal to k minus 1. So k is going to start at 1. Well, we don't have any other constants to mess around with. We do need to make sure that the index is in the same starting point. So the first index starts at 0, the second index starts at 1. So I'm going to want us to start at 1, which means this is going to have the 0th, the k is equal to 0th term going, so that we can start the sum at 1. So when k is equal to 0, we have a 2. When k is equal to 0, we have a 1. K is equal to 0, our subscript is going to be 2. And then we have k to the 0th power. That's just going to be 0, or that's just going to be 1. So this is a constant term. And we don't have any other terms to combine with, so we're going to take this out as a constant term, and we're going to combine these two series. So let's go ahead and do that. Let's take this series here and combine it with this series here. And both of those terms has an x to the k power. And so the x to the k power gets factored out. And then so this is our relationship. So this is equal to 0 or equal to 1, so we can just ignore that. And we have our first value equal to 0. So this is going to easily imply that c sub 2 is equal to 0. So we have a 0 here. Interesting. And now when k is bigger than or equal to 1, so when k is bigger than or equal to 1, we have this relationship here. We want this thing to be equal to 0. So let's get that set up, equal to 0. And then your larger value, or your larger c sub is k plus 2. So let's solve for c sub k plus 2. And then this is going to be in terms of c sub k plus 1. So we bring this over to the other side, it becomes a negative. And then we bring this over, or we have to divide out by this. So this is our relationship. It looks like a fairly simple relationship to work with. So let's work with it, starting with k is equal to 1. So when k is equal to 1, we have c sub 1 plus 2, that's c sub 3. K is equal to 1, we have a 3. 1 plus 1 is 2. K is equal to 1, c sub 0. So we didn't have anything yet with a k's or c sub 0, so this must be your arbitrary constant, or one of them. So that's a good place to start. Now when k is equal to 2, let's see what kind of relationship we're going to get. So k is equal to 2, we have c sub 4. Negative 1, and then k is equal to 2, this is going to be 4, k plus 1 is 3, and 2 minus 1 is 1, so here's our other arbitrary constant. And then we continue. So we'll go k is equal to 3, and this is going to be 5. 5, 4, 3 minus 1 is 2. Now we have c sub 2 somewhere. C sub 2 is equal to 0. So, wow, this whole thing is going to be equal to 0. So c sub 5 is equal to 0. C sub 2 is equal to 0. C sub 5 is equal to 0. C sub 0 is an arbitrary constant. C sub 1 is an arbitrary constant. So it looks like C sub 3 will rely on C sub 0. C sub 4 would rely on C sub 1. And let's see if we can continue that pattern. So we're going to go with C, or K is equal to 4. And when k is equal to 4, this is c sub 6. So we're going in order. Looks good. It's 3, 4, 5, c sub 6. We have a 6 here. We have a 5 here. And we have c sub 4 minus 1 is 3. Now we have a value for that. And it looks like it's this. Let's copy and paste this one first. And let's replace c sub 3 with this expression. So this is going to be something with a c sub 0 in it. And the numerator is going to be a positive 1. So we have a negative 1 times a negative 1, it's a positive 1. And then we have 6 times 5 times, oh, it looks like we're missing a 4 here. So it's just going to be 6 times 5 times 3 times 2. So it's not quite a factorial. We can force to make it look like a factorial by multiplying this to 4 over 4 if we want, but let's just keep it like this for now. All right, we have c sub 4, or we have c sub 6, I'm sorry. So when k is equal to 5, we'll use that same relationship, and then we're going to get c sub 7. So 7 and 6 in the denominator. 7 minus 1 is 6. Oops, 7 minus 5 is what we're looking at. 7 minus 5 is 4. And we have a value for c sub 4. So let's go ahead and replace c sub 4 with the value that we got. C sub 4 is equal to something with a c sub 1. And again, we get a a 1 divided by something and then a c sub 1. So it becomes a positive with the 2 negatives, and then we have 7 times 6 times 4 times 3. And we have c sub 7. Okay, we can continue on with a pattern, but we'll stop here, and then we'll see how this is going to look like. So this is our solution, our general solution, and we want to just put in the values. We don't have value for c sub 1 or c sub 2. C sub 0 is c sub 1, so those are the arbitrary constants. C sub 2 disappears. I wonder if we should just get rid of it. Let's just put a 0 for now. C sub 3, what do we have for that? C sub 3 is equal to this expression, negative 1 divided by 3 times 2 in the bottom, and then c sub 0, so we know that there's a c sub 0 there. C sub 4, we got something for that also. C sub 4 is going to be negative 1 times, or negative 1 divided by 4 times 3. C sub 5 is equal to 0. C sub 6, this is where it starts getting long. And then c sub 7. Okay. Now let's just rearrange this so that all the c sub 0s are together and c sub 1s are together. Let's also, well, we might as well get rid of the zeros, these terms that aren't going to matter for us. And we have c sub 1. And then we have the next c sub 0. And then the next c sub 0 has an x to the 6th. And so we have a couple of patterns here, or a couple of terms, or a couple of solutions. Let's go ahead and take c sub 0 out. So c sub 0 gets taken out. And let's do the same thing for c sub 1. Taken out. So c sub 1 taken out. So here we have our series. We have one series, one that starts with 1. That's going to be a 3x to the 3rd, x to the 6th. And then we have another series that starts with a linear term, and then x to the 4th, x to the 7th. So you can try to imagine what the pattern might look like. We have an alternating series. Our first series goes from 0, 3, 6, and probably 9. Next series starts off with x to the 1st power, x to the 4th, x to the 7th. So it's probably going to be a 4x plus 1 kind of scenario, or 3x plus 1. whatever pattern you might have found. Okay, so this is our second problem.